In the last section, we had a very long discussion about the differences between an imperative and a declarative deployment. In this section, we're going to put a little bit of practice into this and get a very practical example of how we might update an existing object using a declarative approach. So what are we going to update? Well, we're going to say that our new goal, the old goal was to just create a container inside of our Kubernetes cluster. We're going to say that our new goal is to update that existing pod that we created to use the multi-worker image as opposed to the current multi-client image that it is currently using. So essentially what we want to do is find that existing pod and update the image that it uses. Now let's take a quick thought on how we would do this with an imperative approach and a declarative approach. So if we took an imperative approach to this, we might do something like the series of steps you see on the left-hand side. We might run a command to list out all the different pods that we have inside of our cluster right now. And then maybe we would issue a follow-up command to take an ID or something like that out of the current running pod and tell that thing very explicitly that it should now be running a new image. So in this imperative approach over here, we would have to essentially get the current state of our application by running a command to list out the current pods and find some ID of the current pod that is running the multi-client image. We would then have to figure out a migration strategy on our own to update from the current state to our desired state. Now, in this case, figuring out that migration strategy is pretty straightforward. We could probably look up some command API reference and figure out how we could tell a pod to update the image it uses, but again, that would take a little bit of work. So I'm going to suggest that we instead use a declarative approach. With a declarative approach, updating an existing object inside of our Kubernetes cluster is always going to be the exact same process every single time. So we're going to go and find the config file that originally created that pod, and we'll then make an update to it. The update is going to simply say, hey, I want to use a new image. So inside the config file that we used to create the pod, we're going to no longer say, I want to use an image of multi-client. Instead, I now want to use a new image of multi-worker. Once we make that change to the config file, we're going to just throw it into kubectl at the command line, and Kubernetes is going to work to update that existing pod to use the new image. Now, one thing that's kind of interesting about the process of the declarative approach over here is that we're essentially saying that we're going to take this config file, throw it into kubectl, which is, of course, going to forward it on to master, and somehow, magically, the master is going to realize that it needs to update this existing pod as opposed to creating a new one. And that's actually something that's kind of interesting. We're just going to update this config file, and you might notice that inside this config file, there's really no unique ID or anything like that. There's nothing that says, hey, go and find this existing pod, like a pod we already created, and update it. And so it might be a little bit confusing to figure out when making a change to a configuration file will update an existing object, as opposed to just deciding to create a completely new one. So behind the scenes, here's what Kubernetes does anytime that you toss in a configuration file into kubectl and master. So inside of our config file, we're always going to have an object, or we're always going to be creating an object that has a name. So every single last object that you and I ever create with a config file is always going to have a name assigned to it. And in our case, we assigned a name of client-pod. In addition, every single config file we ever put together is going to have an object type assigned to it as well. And technically, it's not labeled in there as the type, it's really labeled as the kind, recall? Remember, right here on line 2, we say kind pod, not object type. But you get the idea. Every config file is going to list out the type of object that we want to create. So every single time that we take a configuration file and pass it into kubectl, the master is going to look at that configuration file and inspect its name and kind properties. It's then going to look at all the different running services inside the cluster, and it's going to say, okay, if I have any other object inside of here with a identical name, and in this case we do, and an identical type, then that must mean that rather than trying to create a new object, I'm going to try to take the updated configuration file and apply all these changes to the object that already exists inside the cluster. So in other words, the name and the kind are our unique identifying tokens for any object that we create. If you ever want to update an existing object, you're going to take your existing configuration file, you're going to always leave the name the same and the kind the same. And then you can change the rest of the configuration file and then feed it all into kubectl. And master is going to automatically find the existing object and make updates to it. Now, if we made a change to the name, so if we said client pod, I don't know, new or something like that, well, it now has a new name. So master is going to say, okay, do I have an existing object that is a pod with the name of client pod new? And in this case, we do not. There's no existing object inside of our cluster with that same name and same object type. And so master would say, okay, well, this is a new name. I guess I need to create a brand new object with that name and that type. So in short, anytime that we want to make an update to an existing object, we just go and find the original configuration file. We'll leave the name and the kind the same, and then we can make any other change we want to inside that file. So with that in mind, let's take a quick pause right here. We're going to come back to the next section. We're going to make an update to our configuration file and then feed it into kubectl, and we're going to expect that it's going to update an existing pod as opposed to attempting to create a brand new one. So quick break, and I'll see you in just a minute.